Dear students, good morning. This is the fourth module of lesson motion. In this module, let us learn graphical representation of motion. At the end of this module, you can able to draw distance time graph and velocity time graph using given data, and also you can able to find out distance traveled by an object from velocity time graph. In our last class, we discussed about acceleration and deceleration. Today, our first topic is graphical representation of motion. To describe the motion of an object, we can use line graphs. So, let us learn how to draw distance time graph. The change in the position of an object with the time can be represented on the distance time graph. So, in this graph, time is taken along the x-axis and distance is taken along the y-axis. Distance time graphs can be employed under various conditions where objects move with uniform speed, non-uniform speed, remains at rest, etc. We know that when an object travels equal distances in equal intervals of time, it moves with uniform speed. This shows that the distance traveled by the object is directly proportional to the time taken. Thus, for uniform speed, a graph of distance traveled against time is a straight line as shown in the figure. The portion OB of the graph shows that the distance is increasing at a uniform rate. Note that you can also use the term uniform velocity in place of uniform speed if you take the magnitude of displacement equal to the distance traveled by the object along the y-axis. So, we can use the distance time graph to determine the speed of an object. Consider a small part of AB of the distance time graph as shown in the figure. Draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet each other at point C to form a triangle ABC. Now, on the graph, AC denotes the time interval T2 minus T1, while BC corresponds to the distance S2 minus S1. We can see from the graph that as the object moves from the point A to B, it covers a distance S2 minus S1 in time T2 minus T1. The speed v of the object therefore can be represented as v equal to s2 minus s1 by t2 minus t1. Students, observe this table. Here the time interval given is equal, but the distance travelled by this time interval is not equal. That means the motion of an object is non-uniform. So, the distance time graph for the non-uniform motion of an object is shown in the graph. Note that the shape of this graph is different from the earlier distance time graph for uniform motion. The nature of this graph shows non-linear variation of the distance travelled by the car with the time. That means this graph is not a straight line, it is a curved line. Our next topic is velocity time graphs. The variation in velocity with time for an object moving in a straight line can be represented by a velocity time graph. In this graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at uniform velocity, the height of its velocity time graph will not change with the time as shown in the figure. It will be a straight line parallel to the x-axis. The velocity time graph for a car moving with a uniform velocity of 40 km per hour is represented in this graph. We know that velocity is equal to displacement by time. So displacement is equal to velocity into time. In a straight line motion, the displacement and the distance are equal. To know the distance moved by the car between the time t1 and t2 using the given figure. Draw perpendicular from the points corresponding to the time t1 and t2 on the graph. The velocity 40 km per hour is represented by the height AC or BD, and the time t2 minus t1 is represented by the length AB. So, the distance S moved by the car in time t2 minus t1 can be expressed as S equal to AC into CD. That is equal to the area of rectangle ABCD. Here another table for you. The time interval given in this journey is equal, that is 5, 10, 15, etc. The interval of this time is 5 seconds. And again the velocity is increasing in uniform rate. You can see that in our table, that is 9, 18, 27, 36, etc. So this is a uniform accelerated motion. The velocity time graph or a car moving with uniform acceleration is shown in the figure. The nature of the graph shows that velocity changes by equal amounts in equal intervals of time. Thus, for uniformly accelerated motion, the velocity time graph is a straight line. You can also determine the distance moved by the car from its velocity time graph. The area under the velocity time graph gives the distance moved by the car in a given interval of time. If the car would have been moving with uniform velocity, the distance travelled by it would be represented by the area ABCD under the graph. This we already discussed. Since the magnitude of the velocity of the car is changing due to acceleration, that means the body is in uniform acceleration, the distance s travelled by the car will be given by the area of ABCDE under the velocity time graph, that is S equal to, S means the distance traveled, is equal to area of ABCDE. Here ABCDE is a trapezium. We can divide this trapezium into a rectangle and triangle as shown in the figure. So area of ABCDE is equal to area of rectangle ABCD plus area of triangle ADE. That is equal to, what is area of rectangle ABCD? It is L into B. That is equal to AB into BC plus area of triangle is half into AD into DE. In the case of non-uniformly accelerated motion, velocity time graphs can have any shape. In figure A shows a velocity time graph that represents the motion of an object whose velocity is decreasing with time, while figure B shows the velocity time graph representing the non-uniform variation of velocity of the object with time. Students, in this module we discussed about graphical representation of motion. Hope you understood this module. Read your textbook thoroughly and watch this video carefully. Thank you.